We live surrounded by video, yet we almost never ask how it moves so effortlessly through our lives. We tap a screen and a moment recorded somewhere else by someone we will never meet appears instantly in front of us. It feels natural now, almost biological, as if moving images were always meant to flow this way, weightless and obedient. But this ease is an illusion created by decades of struggle, compromise, and quiet engineering. Before a video became fluid, it was heavy. Before it was universal, it was fractured. Before it lived in our pockets, it lived behind error messages, progress bars, and incompatible machines that refused to speak the same language. This documentary is not about a camera, a platform, or a viral moment. It is about the invisible agreement that made modern video possible at all. The container that stopped the fighting, erased the borders, and allowed billions of devices to cooperate without asking permission. To understand how video conquered the internet, the smartphone, and eventually everyday life itself, we have to look past the screen and into the structure that holds everything together. This is the story of how silence, standardization, and an unremarkable file extension changed the way the world sees itself. In the history of human communication, the loud revolutions get the statues. The printing press, the radio tower, the first television broadcast that pulled moving faces out of the air and into the living room. Those are the moments that feel like turning points because they announce themselves. They arrive with spectacle. They give you a before and after you can point to. But there is another kind of revolution, quieter and more consequential, the kind that slips under the surface and becomes a condition of life rather than an event. These are the revolutions of standards, agreements that are not laws, not products, not inventions you can hold in your hand, but rules that machines accept so thoroughly that they begin to share a single grammar. And when that grammar is in place, the world appears to change overnight. Even though the work happened years earlier in committee rooms, in drafts, in test files that never left a lab. Today it is so normal that it barely registers. A video recorded on a phone in Tokyo plays instantly on a laptop in London and a television in Sao Paulo. You tap a thumbnail and it moves. You do not negotiate. You do not translate. You do not wonder whether your device speaks the same dialect as the file. Most of the time, you do not even see the container. You might notice the extension only when something breaks, when you are forced to look at the plumbing. The quiet truth is that modern video is held together by a container that became so stable it effectively disappeared. The extension is small, almost insulting in its simplicity. .mp4. To understand why that matters, you have to return to a time when digital video was heavy, when every attempt to move a few minutes of footage across a computer felt like dragging furniture through a narrow hallway. Imagine a computer lab in the mid-1990s. Beige plastic towers, loud fans, a forest of CRT monitors throwing pale light across desks scattered with disks and manuals. The air carries the smell of warm circuitry and dust baked by power supplies. On a screen, a progress bar inches forward with the stubborn patience of geology. Someone is trying to play a short clip, 3 minutes maybe, the kind of thing that would now be an afterthought embedded in a message thread. Back then, it is an ordeal. And the ordeal begins with a word that feels less like a technical term and more like a gatekeeping ritual. Codec. If you have the wrong one, nothing happens. You might have a file named with confidence, ending in .org, and yet it opens like a locked door because the audio and video inside were encoded using something your machine does not understand. The error message is blunt, a refusal that feels personal when you have waited all night for a download to complete. Unknown format. Codec not found. It is not just inconvenience. It is a cultural condition, an everyday reminder that computers, for all their promise, were still bad at agreeing with one another. In that era, the average user sees a video file as a video file, a single object that either plays or does not. But the people who built the systems knew a more uncomfortable reality. A file extension was not the content. It was a wrapper, a shipping crate, a container that might hold compressed video and compressed audio, maybe subtitles, maybe other information. And each of those elements might be created using different compression methods, different assumptions, different licenses, different companies. In the 1990s, the shipping crates were crude and often proprietary. Some were designed to ride only on a specific company's ships. Some had no reliable manifest. You did not know what was inside until you opened it, and by the time you did, it was too late to fix the mismatch. The result was a kind of daily friction that shaped behavior. People avoided sharing video because sharing video was risky. Professionals hoarded specific workflows because a workflow that worked was precious. An editor who had a set of codecs installed in a stable timeline that did not crash treated that system like a fragile ecosystem. And creatives developed a particular kind of superstition because nothing in early digital video felt guaranteed. You might do everything right and still lose hours to a crash at the final stretch. Part of the heaviness was literal. Uncompressed video is enormous, and the early digital era did not have room for it. A single minute of uncompressed standard definition footage could balloon into a size that made the math absurd in the context of consumer hardware. Hard drives were small, expensive, and temperamental. A high-end home machine might offer hundreds of megabytes when a single gigabyte felt like a luxury for professionals. That meant video could not exist on computers unless it was compressed, and compression, at the time, was a battlefield of competing ideas and competing business strategies. The need to shrink the moving image birthed the first true format wars of desktop media. Not the old war of VHS and Betamax fought in stores, but an internal war fought in operating systems and software suites, in which file formats became borders and codecs became visas. Apple made an early bid to civilize the chaos with QuickTime, introduced in the early 1990s, a moment that is easy to underestimate now because it did not arrive with mass hysteria. It simply made it possible for a computer to play synchronized audio and video in a window on the desktop. That sounds basic, but it was a statement about what a personal computer could be. QuickTime was elegant, but it was also culturally coded. It lived in the Mac ecosystem, and that meant it could become a symbol of creative professionalism and, at the same time, a source of resentment for anyone living on the other side of the platform divide. On Windows, Microsoft responded with Video for Windows and the AVI container, Audio-Video Interleave, a format whose very name describes the straightforwardness of its approach. It was the brute force solution, a practical container that placed audio and video together in a way that made sense for the hardware of the system. AVI spread everywhere because Windows spread everywhere. But being everywhere is not the same as being future-proof, and AVI carried the fingerprints of its era. It was designed for local playback from disks, not for the unpredictable speeds and interruptions of the early internet. It did not gracefully support variable bit rates. It struggled with newer compression features. It lacked the kind of flexible metadata structure that would later become essential. And perhaps most importantly, it did not solve the human experience of codec chaos. An AVI file could contain video compressed with one of many codecs. from popular ones to obscure proprietary ones. And without the exact tool to decode the cargo, the container was meaningless. This is where the phrase codec hell becomes more than a meme. It describes the lived experience of a generation of early digital media users. When the file arrives, it looks familiar, it refuses to play. You search for a codec pack. You install something from a shareware site. Now another file plays, but your system becomes unstable. You become cautious, then paranoid. In offices and classrooms, people trade codec installers the way travelers trade advice about border crossings. Meanwhile, the broader culture is still tied to physical media, because physical media is the only reliable bridge between machines. If you want to share a video, you hand someone a CD-ROM or a disk. The internet is too slow to be trusted. Dial-up modems sing their electronic handshake, and the idea of streaming feels like science fiction. You do not watch while data arrives. You download, often overnight, hoping the connection does not break at 98%, and if it does, you begin again. The format story of the 90s also reveals a deeper psychological tax, the one paid by creators. The lack of a unified, interoperable standard meant time itself was consumed by translation. Editors and producers spent enormous hours transcoding simply to get from one walled garden to another. A file created in one environment needed conversion to be edited elsewhere. And conversion meant rendering, and rendering meant waiting. The render bar became a symbol not just of computation, but of helplessness. You could not speed it up with willpower. You could only hope it finished without crashing. Hope the machine did not run out of memory. Hope the driver did not fail. Hope the software did not decide to corrupt the output at the end. Workdays were structured around renders. People started them before leaving for the night. They returned in the morning like gamblers checking the outcome of a long bet. Sometimes they won. Sometimes they lost hours to a single error. This was the friction that shaped the pre-MP4 world. And it is important because it explains why the eventual winner did not need to be flashy. It needed to be reliable. It needed to remove pain. As the decade approached its end, it became obvious that the future would not belong to physical media alone. The web was growing. People wanted to share more than text and small images. They wanted moving pictures that could travel across wires. But existing standards had been built for different assumptions. MPEG-1, the basis of video CD, could deliver acceptable quality for disk era, but not the fidelity people would soon expect. MPEG-2, the backbone of DVD, was beautiful within the context of high-storage physical media, but it was heavy. It was designed for predictable pipelines, not for the variability of network delivery. The internet, especially at the time, was a harsh environment. Bandwidth was scarce. Connections dropped. Speeds fluctuated. If video was going to become a networked medium rather than a local artifact, it needed new architecture. It needed a container built not for a single machine and a single disk, but for a world of diverse devices, diverse connections, and constant change. This is the point where a relatively obscure institution becomes one of the most important forces in modern culture, not by creating a product, but by writing rules. The Moving Picture Experts Group, MPEG, a committee of engineers operating within international standards organizations, recognized that digital media would not scale without interoperability. In the late 1990s, as the web expanded and early mobile networks hinted at a future of portable connectivity, these engineers began drafting what would become ISO and IEC standards, known collectively as MPEG-4. This was not merely a new codec. It was a reimagining of media as a system, a philosophy as much as a specification. The guiding idea was a low bitrate dream. Bandwidth would always be a constraint, whether you were on dial-up or a nascent cellular network, and the goal was to deliver acceptable quality at minimal data cost. But the ambition went further. The early MPEG-4 vision treated media not just as a flat stream, but as objects. Instead of compressing an entire frame as a single slab of pixels, the system imagined separate components that could be transmitted and composited, a person as one object, a background as another, audio elements as separate tracks. Much of this object-based complexity proved too advanced for typical hardware in the early 2000s, but the philosophical shift mattered. It seeded an architecture in which a media file would become a modular collection of tracks and metadata rather than a dumb blob. That modularity would later enable everything people now take for granted, from multiple audio languages to subtitle tracks to chapters and rich metadata that turns a folder of files into a library. When the committee approached the question of a file format, the container itself, they faced a choice with consequences that would ripple across decades. They could design a brand new file format from scratch, risking years of development and a failure to gain adoption. Or they could base the new standard on an architecture that already existed, one that had proven flexible in real-world use. They looked to Apple's QuickTime file format not as a corporate endorsement, but as an engineering acknowledgement. Despite platform rivalries, the QuickTime structure was elegant. It organized data in a hierarchical way, using nested units that Apple called atoms, units that would later be called boxes in the standardized terminology. This structure made files easy to parse, flexible to extend, and resilient to evolving needs. In the early 2000s, the standards world effectively made a grand bargain. The QuickTime file format became the foundation for an international standard known as the ISO-based media file format. And out of that foundation came the specification most people would eventually encounter as MP4, formerly MPEG-4, Part 14. The birth of MP4 was not a public event. There were no keynotes, no advertising campaigns, no dramatic unveiling. It was paperwork, documentation, a PDF. And that is precisely why it represents the kind of silent revolution that changes everything. What the specification offered was not a shiny feature, but a promise: interoperability. If you followed these rules, your file would be readable by any system that also followed these rules. That sounds obvious now, but it was the antidote to the codec era's chaos. Just as important, the container was designed with network delivery in mind. It could support streaming readiness in a way older formats did not. It could be structured so that a player could learn what it needed quickly and begin playback sooner. The container was a tool for removing friction in an emerging world where friction would decide winner. To see why, it helps to open the container and look at its structure, not as a purely technical exercise, but as an act of cultural archaeology. The MP4 container is often confused with a codec, and that confusion is understandable because in everyday life the two travel together, but they are different layers. The container is the organization, the packaging, the index. The codec is the method of compressing and decompressing the actual audio and video streams. Think of a shipping container on a cargo ship. The steel box is the container. The goods inside could be anything. In the pre-standard days, some containers were like wooden crates nailed shut, messy, inconsistent, and often reliant on secret knowledge to open. MP4 was engineered as a smart box, a container with a manifest and a table of contents. It does not just hold the cargo, it tells you how to find it. This organization is built from boxes, nested inside one another, each box a typed unit of data that can contain other boxes or raw media. Near the beginning of an MP4 file, there is a file type box, a kind of passport, that declares the file's identity and compatibility. There is a movie box that holds metadata, the map of the file, information about tracks, timing, and where to locate the samples of audio and video. There is a media data box that contains the compressed audio and video payload itself, typically the vast majority of the file's size. The elegance is not in any one of these elements, but in the concept that the file is a hierarchy with an intelligible structure, a system that a player can parse deterministically. This is what makes the container extensible. It is also what makes it future-proof in a way older formats were not. If you want to add a new kind of metadata or a new kind of track, you can define boxes for it without breaking the entire paradigm. The container evolves without needing to be reinvented. There is one technical detail that sounds mundane until you realize it reshaped the culture of web video. Early on, many encoders placed the movie metadata box, the map, at the end of the file. That meant if you were trying to watch a large video over the internet, your player might have to download the entire file before it reached the metadata necessary to begin playback. This produced the familiar experience of the early web, the waiting, the spinning cursor, the sense that video on the internet was always a compromise. The MP4 structure allowed a simple but powerful fix. Put the map at the beginning. Move that metadata box ahead of the media data so the player can understand the file immediately, then begin playing as the payload arrives. This is sometimes called fast start, and it is difficult to overstate its cultural impact. It is the difference between video as a download chore and video as a click and watch medium. It is the difference between a web page that feels like static information and a web page that feels like a channel. It is the difference between the early internet's patience economy and the later internet's attention economy. When video becomes immediate, it becomes addictive. When it becomes addictive, it becomes central. A container architecture helped make that possible. The MP4 container also normalized metadata as a first-class citizen in media files. Older approaches often treated audio and video as the only real content. MP4, by contrast, made it natural to include descriptive data, titles, artists, years, even artwork, chapters, and other contextual information that transforms a file into an object in a library rather than a random blob in a folder. This matters because culture at scale depends on organization. When a platform like iTunes built a store around video and music, it relied on metadata to make browsing and sorting meaningful. When later platforms built recommendation engines, they relied on consistent formats and consistent metadata hooks. The container became not just a way to hold streams, but a way to carry identity. It made media legible to machines, and when media becomes legible to machines, it can be indexed, searched, categorized, and monetized. Another quiet genius of the design was that the container did not care what the cargo was, at least not in a narrow proprietary sense. It was codec agnostic by design. Although it is most famous for carrying H.264 video and AAC audio, the container could adapt to new codecs as they emerged. The shipping container stays constant while the goods inside become more efficient. This stability is one reason MP4 remained viable through massive transitions, from standard definition to high definition, from high definition to 4K, and beyond, from older compression methods to newer ones, while preserving the same overarching file paradigm. In technology, longevity is rare, and when it occurs, it is usually because a standard found a way to be both rigid enough to guarantee compatibility and flexible enough to survive change. MP4 managed that balance. But a good standard is not automatically a winning standard. Technology is not a meritocracy. It is an ecosystem shaped by incentives, adoption, and power. In the early 2000s, digital video was still a series of warring city-states. Microsoft had its formats and its platform leverage. Apple had its creative prestige and its ecosystem. Adobe, through Flash, had a near-universal foothold in the browser, and the average user had little patience for any of it. In that environment, MP4's most important feature was not a technical spec. It was neutrality. It belonged to no single company in the way proprietary formats did. It was standardized through international bodies, and that meant no single vendor could change the rules to punish competitors or lock users in. That neutrality made MP4 feel safe. It was the Switzerland of digital media, a place where companies could meet without surrendering sovereignty. Microsoft's AVI had the advantage of incumbency, but its weaknesses became more visible as the world shifted toward network delivery and more complex media needs. Microsoft's answer, Windows Media Video and its associated container ecosystem, was technically impressive, often delivering strong compression. Yet it was culturally and strategically constrained by its identity as a Windows format. Playing it elsewhere required plugins, workarounds, and compromises. Apple's MUV, rooted in QuickTime, remained beloved by creators, but it carried its own ecosystem gravity. Meanwhile, Flash Video, delivered through Adobe's Flash Player, became a temporary solution that looked like it might win by sheer distribution. In the mid-2000s, Flash was installed on the overwhelming majority of browsers. If you wanted video to play in the browser without forcing users to install codecs, Flash seemed like the path of least resistance. It was not the most elegant. It was not the most open. But it worked. And working is often the only argument that matters. Yet Flash carried fatal flaws that would surface as the center of gravity shifted from desktop to mobile. It was proprietary. It depended on a plugin. It was resource-heavy. It consumed battery and CPU cycles in ways that became unacceptable in the era of smartphones. Flash was a web solution rather than a device everywhere solution, and the future was clearly device everywhere. The turning point did not come from a standards meeting. It came from products that reframed the market's incentives. When Apple introduced devices that made portable video consumption mainstream, first through the video iPod and then far more decisively through the iPhone, the company made a strategic choice that had the effect of collapsing the format war into a single obvious target. Apple could have doubled down on a proprietary approach. It could have treated its own formats as a lock-in mechanism. Instead, it leaned heavily into the MPEG ecosystem, pairing H.264 video with the MP4 container. This was not altruism. It was strategy aligned with product goals. If Apple wanted its devices to become universal media players, it needed content that could be produced by the broader world. By embracing a standard container, Apple gave creators a clear directive. If you want your video to play on the hottest new device, it should be MP4. That directive should be MP4. That directive changed behavior at scale. It shifted creators, encoders, camera manufacturers, and software developers, and it put pressure on platforms. YouTube, when it launched, relied on Flash for practical reasons. It was the fastest way to make video play in the browser because the plugin was already everywhere. But as mobile traffic surged and the world demanded video on phones and tablets, Flash became a liability. The web itself began to pivot toward native video playback through HTML5, a shift that was not just technical, but political, a movement away from proprietary plugins toward standards that browsers could implement directly. In that new world, MP4 became the backbone of web video because it was widely supported and because devices had hardware acceleration for its common codecs. YouTube began transcoding vast libraries into H.264 within MP4, not because MP4 was magically perfect, but because it was compatible across the devices people actually used. This is the rule that emerges again and again in media history. The most compatible format beats the format that is marginally better in any narrow technical sense. A proprietary format might offer slightly smaller files or slightly better quality. It does not matter if it breaks for the user. In a world of billions of users, every point of friction is a death sentence. By the early 2010s, the war was effectively over. AVI persisted as a legacy format and an archive artifact. MV remained in niche enterprise contexts. Flash entered its long decline, kept alive by inertia until security concerns and mobile incompatibility finally made it untenable. MP4 stood as the default, not in the triumphant way a brand stands, but in the invisible way infrastructure stands, a floor that everything else is built upon. This is a strange kind of victory. It does not feel like conquest. It feels like settling. It feels like the moment a language becomes common and stops being noticed. Then came the period when the consequences of that settling reshaped human behavior. Between roughly 2010 and 2020, video consumption underwent a tectonic shift. The center of gravity moved from living rooms and desks to pockets and hands. The smartphone became not just a playback device, but a camera, an editing station, an upload terminal, a broadcasting hub. For the first time, billions of people carried a device capable of recording high-quality video and sending it across the network without special knowledge. This mass participation in video creation did not happen simply because cameras improved. Cameras had improved before. It happened because the output was compatible. The device recorded in a format that would be accepted almost everywhere, and that format was typically H.264 in an MP4 container. The heavy pixel became manageable. Compression became invisible. The upload became routine. In effect, the MP4 container helped turn video into a daily language rather than an occasional artifact. This shift had profound social consequences. Citizen journalism, live documentation of events, the ability to record and share truth from the street, all of it depended on a chain of technical assumptions that culminated in the fact that a file recorded on one device would be playable on others. In unstable network conditions, robust packaging mattered. When uploads were interrupted, when networks dropped packets, when mobile connections fluctuated, having a container structure that could be parsed and, in many cases, still played even if some data was missing improved reliability. It reduced the fear of failure. It encouraged recording because the outcome felt less fragile than it had in the 90s. the same time, social media platforms emerged not merely as apps, but as industrial-scale media processing plants. Every second, vast quantities of video were uploaded, transcoded, packaged, and served to other users. These platforms needed a universal input because supporting every format was expensive and messy. They needed a standard pipeline, and MP4 fit that role. When you upload a video to a platform, the servers often check the container and then transcode it into their preferred delivery formats, embedding their own metadata, identifiers, and processing hints. MP4's extensibility made it possible to carry information about the media without breaking playback. It became a practical default for ingestion and for distribution. And because the platform shaped culture, their defaults became society's default. Then video got shorter, and the internet's rhythm changed. Short-form video platforms and features did not just thrive because attention spans shrank. They thrived because the infrastructure made frictionless playback possible at scale. When a user swipes to the next clip must start instantly or the spell breaks. That instant start is enabled by streaming techniques that rely on fragmented delivery, where a file can be divided into small segments and played as it arrives. MP4, through related standards and packaging methods, became central to that. The effect is psychological. When the screen never pauses, the user never leaves. The infinite scroll becomes not merely a design pattern, but a behavior-shaping machine. And behind that machine is a standard that allows predictable delivery to an astonishing diversity of devices. The container becomes a tool for behavioral economics. It is not just about video, it is about time. By the mid-2010s, the very concept of downloading a video file began to feel archaic for many users. Streaming became the dominant mode. Video became something you access, not something you own. This transformation had many drivers, from bandwidth improvements to business models, but it also depended on a stable baseline of compatibility. MP4's dominance was reinforced by hardware. Modern devices include specialized chips or circuitry optimized to decode common MP4-associated codecs efficiently. That means playing such video consumes less battery and less CPU than more exotic formats. Hardware support creates inertia. Inertia becomes permanence. When billions of phones, televisions, cameras, cars, and appliances can decode a particular container and codec combination in silicon, it becomes extraordinarily difficult to dislodge it. A new standard might be better on paper. It will still struggle against the reality that old standards are built into the world. This is where the story enters its final phase, the phase of invisibility. In the philosophy of technology, there is a moment when a tool becomes infrastructure. Once it is infrastructure, it stops being a topic. People do not debate it in everyday life. They assume it. They notice it only when it fails. MP4 reached this status. In a fast-moving software world, a 2-decade-old standard should be a fossil. Yet MP4 persists because it sits at the intersection of global agreement and physical deployment. It is documented as an international standard. It is implemented everywhere. It is supported in hardware. It has become a kind of permanent default. That permanence also has consequences for memory and preservation. We live in the most documented era in human history. Petabytes of video are uploaded daily, recording lives, events, jokes, atrocities, art, instruction, propaganda, everything. Digital data is fragile, and yet standards create a pathway for future readability. A proprietary format is a locked box if the keys disappear. An internationally standardized format, publicly documented and widely implemented, has a better chance of remaining legible across time. Even if companies vanish, documentation remains. Engineers in the future can reconstruct decoders. Archivists can parse files. In that sense, MP4 has inadvertently become a preservation layer for our era's visual memory. It is not perfect. Nothing digital is perfectly safe. But compared to formats tied tightly to a single vendor's goodwill, a neutral standard is a form of resilience. And then there is the newest chapter, the one that makes the story feel almost cyclical. As generative AI begins to create video, not as a recording of light on a sensor, but as a synthetic output of models, the question emerges quietly. How do these new creations enter the existing world? In what form do algorithmic dreams become shareable objects? Almost always they arrive as MP4. The model does not care about standards history, but the distribution ecosystem does. If you want a video to be seen, to play on phones, to upload to platforms, to embed in feeds, you choose the container that the world already understands. The MP4 box becomes the bridge between human-captured reality and machine-generated imagery. It is a reminder that even the most futuristic media still needs a mundane package to travel. This is the core irony of MP4's success. It did not win by being glamorous. It won by being unselfish. It won by getting out of the way. In the format wars, companies often tried to use video formats as leverage, as a means of keeping users within borders. MP4 offered a neutral ground, an agreed-upon shipping container that let everyone trade. That neutrality made it attractive to platforms, attractive to device makers, attractive to creators. It invited optimization. It invited hardware support. It invited a virtuous cycle in which widespread adoption made it more valuable, and its value drove more adoption. Eventually, it became so common that it stopped being a choice. It became the default assumption of video itself. So if you look back to the 90s, to that computer lab where a 3-minute clip could refuse to play because of a missing codec, you can see what changed. The digital world did not become smooth because bandwidth alone improved, and although it did. It became smooth because the container became stable. Because the rules of packaging became universal enough, the devices could stop arguing about how to open the box. The heavy pixel became lighter, not only through better compression, but through better organization. The render bar's tyranny faded, not only because computers got faster, but because workflows became more predictable. And the world's video culture exploded, not only because cameras became ubiquitous, but because the files they produced spoke a common language. The real legacy of MP4 is not that it is the format of YouTube, or the iTunes Store, or smartphones, though it was central to all of them. The legacy is that it made modern video feel inevitable. It made the act of watching and sharing moving images feel as simple as breathing. It turned what used to be a technical challenge into a basic human action. A moment happens, a device records it. The world can see it. Somewhere beneath that simplicity, a small structure of boxes and metadata is quietly instructing silicon how to map time and sound and motion into experience. You do not see it. You rarely think about it. But without it, the digital world would fall silent in a familiar way. The old friction would return. The borders would reappear. The weight of the 90s would settle back into our hands. In the end, MP4 is one of those inventions that does not feel like an invention because it was not a single person's spark, but a collective agreement, a committee's architecture, a set of constraints that made freedom possible. It did not change video by adding spectacle. It changed video by removing obstacles. It is the standard that changed everything because it made everything else easier to build. And that is why it became invisible. Because the most successful infrastructure is the kind you forget is there until you imagine the world without it. And suddenly you can hear the old noise again, the errors, the broken playback, the long waits, and the heavy silence between what you wanted to share and what the machine was willing to show. By now, the story should feel less like the rise of a file format and more like the construction of a hidden system, one so successful that it dissolved into the background of daily life. The triumph of this standard was never about dominance or spectacle. It was about removing friction so completely that we stopped noticing it had ever been there. When technology works at this level, it no longer feels like technology. It feels like reality. Every clip you watch, every memory you record, every moment that travels instantly from one side of the planet to the other carries the legacy of these decisions, these structures, these quiet rules that refuse to belong to any single company or era. And this pattern repeats across history. The most powerful technologies are rarely the loudest. They are the ones that disappear into infrastructure and quietly reshape behavior at scale. If the story changed how you see something as ordinary as a video file, there are many more invisible systems worth examining. If you want to explore the hidden architecture behind the tools, platforms, and standards that define modern life, consider subscribing, sharing this documentary with someone who still thinks formats do not matter, and leaving a comment about which unseen system you think deserves the next deep dive. Because the future is not built only by breakthroughs we celebrate, but by standards we agree to and then forget.